Hello everybody, in this video I'm going to discuss the difference in meter in speed control versus meter out speed control with regards to a tractive load. A tractive load is a load that is vertical. As a result, the gravity has an effect on the motion of the piston. So in the first circuit, I'm going to show you how a meter in circuit controls the tractive load, and in another one I'm going to switch the connections to meter out and see how it affects the speed of the vertical load. So from this neutral position, if I switch to extension position, this flow control valve will try to control the descent of this piston just like this. So you can see the piston is coming down. I'm going to go and slow down the speed a little bit to stop and explain for a moment that what is happening here actually. So during extension using a meter in connection such as this one, this FCV will try to control how fast this thing descends. However, during extension, the piston is not only pushed down by the pump here, but also is pulled down by the gravity. Okay, and because the gravity is in play, if the load is large enough, then the gravity will become so large that the piston may actually disregard the restriction set by these FCV. And that could lead to undesired results. Also, during the descent, if you notice, the rod side of the piston, okay, so the fluid under the piston is connected directly to the tank, which sets the pressure of this fluid under the piston to 0. So gravity will pull down the piston under such condition as fast as it can, because it literally falls like a free fall, because the fluid on the rod side doesn't pose any challenge to the piston's descent, so it literally can free fall. So when this happens, due to this fast descent, a void is created above the piston, and it creates so fast that the pump simply cannot keep up, and it fails to refill this void quickly enough with fluid. This results in a partial vacuum above the piston, and you can see the vacuum is measured by this pressure gauge in this line. So there's a depression in this line, which is clearly shown by -1 bar pressure. So it's a -1 atmosphere inside of this of the blind end of the cylinder. This is similar to what happens when we try to suck in liquid medicine into a vaccine syringe by pulling down on the piston. Same thing is happening here. This negative pressure is due to the vacuum that we momentarily create above the piston, and we must avoid the formation of such negative pressure for two reasons. First of all, the extreme low pressure above the piston may cause the liquid, whichever we are using in the fluid power system, to evaporate and cause cavitation, and cavitation can lead to damage in the system, physical damage of the system. Secondly, the piston undergoes kind of force imbalance on either side. So it feels a pull above it and a push due to the gravity. So there's a force imbalance which can actually seize the piston in place, or it can even break the system altogether. So this is what happens in a meter in connection when you are trying to descend a heavy load. Okay, so I'll continue with normal speed. You see continuously this one suffers a low pressure, and this fluid is easily traveling back to the tank, which causes the entire downstream line to be at 0 pressure. When we do the retraction, the piston is pushed up by the fluid under the piston. This motion is against the effect of gravity, and as a result, it doesn't cause the load to run too fast, so there's no chance of a cavitation or any physical damage. So retraction is fine. However, during extension, as we have seen, bad things can happen. So meter in connection are not usually recommended for tractive load. So let's have a look at meter out connection now. So here I have a meter out connection, same load and everything, and we have meter out, as you can see by the orientation of the unidirectional flow control valve with respect to the blind end and the rod end. So both of them are flipped 180 degree compared to our last circuit. So in this one, if I try to extend, you can see on this line there is no negative pressure above or below the piston. If I retract it, same thing, nothing is happening that can lead to vacuum in the cylinder, and that doesn't that as a result we don't see any negative pressure anywhere in the circuit. So we'll wait until it goes up all the way, and then I'll extend again. So what happens is the incoming fluid does not control the speed. This one is not controlling the speed of extension. This one does. The outgoing fluid is affecting the speed. Because of the way they're connected, the fluid under the piston is not connected directly. So if I switch to this and freeze it in time, you can see the fluid on the rod side is not directly connected to the tank. It has to go via the FCV, which poses some restriction. So this part of the line is still at positive pressure, above atmospheric pressure, and this line is connected to the tank. So this part of the line is at 0 bar, while this one is not. So this means the rod and fluid has certain resistance to offer when the piston is trying to descend. It's not a free fall anymore. So in this type of connection, both pump pressure and gravity pulls down on the piston just like before, but the two forces literally have to work hard to get the fluid under the piston out before they can come down. This restriction doesn't allow the piston to descend too fast or create any vacuum above the piston. So that's why meter out connections are always better when you move a vertical or tractive load. Okay. Hopefully this helps to understand the difference between the meter in and meter out speed control mechanism. Meter ins are pretty good for resistive load, which are horizontal load, no problem at all. But the meter outs are usually preferred when it's a large tractive load that we need to move. Hopefully this was understandable, and hopefully this one helps clearing up some doubt about the two types of connections. Thank you very much.